Okay, well, we might make a start. So, hello and good evening, everyone, and welcome to our first of our series of online webinars called The Nature of Change in Port Phillip Bay. This is a collaboration between Lifesaving Victoria, the Association of Bayside Municipalities, and the Victorian National Parks Association. So my name is Shannon and I'm a nature conservation campaigner with the VNPA, and we'll just be giving you a brief introduction before we get into the wisdom of the evening from our special guest speakers. So first of all, I'd really love to recognise that different parts of Port Phillip Bay are a really important part of sea country for the Bunurong people on the northern and eastern side of the bay, and on the western side of the bay for the Wadawurrung people, and really acknowledge that there's so much rich cultural history that has been alive for thousands of years before this time. And so we acknowledge the elders past, present and future, and thank all traditional custodians for caring for Port Phillip Bay for over thousands of years, and giving us inspiration for how we too can continue to live, work and play respectfully and tread lightly on this country. So these webinars have come from the fact that Port Phillip Bay is a constantly changing environment, and we acknowledge that there's many changes that have happened in the past, in history, that many changes that are happening now, and many changes that will continue to happen in the future. And when we can bring some greater awareness and have conversations and increase our knowledge about what these changes are, this can better adapt the way we live, work and play around its waters and its shores. So was born our first webinar to really kick off this series, and we're going to take a trip back in time a long, long ago. And we have two very incredible speakers with us tonight, which I'm going to hand over to Paul very shortly to introduce. So not only will you get to hear the wisdom from these speakers tonight, is you'll get a chance to ask questions. And so we offer that to ask questions throughout the speakers is totally fine, and please do that in the Q&A function at the bottom of the screen. So just pop in your questions there and who your question is for, and we'll endeavour to get to as many of those as possible at the end. And it's best not to raise your hand, but just use the Q&A function there. So we also just wanted to recognise too that we don't have a speaker to represent the First Nations perspective and story tonight. And as you can imagine, there is a lot going on this week with the very important Voice to Parliament. So, but we just wanted to let everyone know that we endeavour to continue to have a First Nations representative and voice at one of these webinars in the future. So this event is also run thanks to the Victorian Government for funding to support the event. And we also have another one coming up on the 22nd. More on that later. Without further suspense, I think it's time that I pass over to Paul from Lifesaving Vic to introduce our speakers.
Thanks, Shannon. And Lifesaving Victoria is thrilled to be able to co-host with you guys with this Coast Care grant online, and we have a couple of in-person events coming up later as well. So over the next 8 months, stay tuned and we'll feed through the information. But a great partnership between Victorian National Parks Association and the Association of Bayside Municipalities. So from a Lifesaving Victoria perspective, we've got 26 lifesaving clubs around the bay, and they see themselves, the members in those clubs see themselves as the coastal custodians of public safety on Port Phillip Bay. But they're now experiencing firsthand the nature of environmental change within the bay, and are keen to be part of normalising the conversation around what we can do. So in the quest for further knowledge, it is now my great pleasure to introduce, first of all, Ben Francischelli, a passionate vertebrate paleontologist whose work takes us on a remarkable journey through time along the southern coastline of Victoria. For the past decade, Ben has been exploring this coastal region unraveling the secrets of ancient creatures such as whales, sharks, and megafauna. In collaboration with citizen scientists, his expeditions have shed light on the prehistoric world that once thrived beneath the waves. Currently serving as a visiting curator at Bayside City Council, Ben is crafting an intriguing fossil-based exhibition titled Prehistoric Bayside, set to captivate audiences in June 2024. Furthermore, he holds the role of a science and conservation communications advisor at Parks Victoria, where his expertise contributes to environmental stewardship. In his upcoming presentation, Ben will transport you back in time, unveiling the transformation of Port Phillip Bay and the Greater Melbourne region over the past 100,000 years. Prepare to be astounded by the functional anatomy of some of the most extraordinary creatures to ever roam the earth, from giant short-faced kangaroos to the awe-inspiring jaws of the largest marsupial carnivore in history. Ben will also delve into how the bay took shape during the last ice age and the unique species that have only recently vanished with European occupation. Ben Francischelli's captivating exploration of the prehistoric world promises to be a journey through time and evolution like no other. So with that, Ben, over to you.
That was one of the best introductions I've ever been given for anything, Paul. Wow, thank you so much. That was lovely.
I thought I might have stretched it a little too long, but I aimed for a minute.
No, that was great. Thank you so much for all of this, guys. And thank you, Shannon, as well, for organising this webinar. I'm incredibly excited to present on the topics tonight. And David as well, thank you for being a part of this. I'm super excited for your presentation after mine. Without further ado, what I'm going to do is I'm going to share my screen and make sure that we get everything up and going. Can we all see that?
Yeah.
Yes?
Yes.
Excellent. Fantastic. We'll get into it right from the beginning. 100,000 years ago, we're going to be traveling back in time as the mirror goes over the facade. And it's pretty hectic, the last 100,000 years of evolution, not just of Port Phillip Bay, because it didn't exist 100,000 years ago. It only came into existence at the last glacial estimate of about 6,000 to 10,000 years ago. But the fauna that existed there was absolutely extraordinary. And I can't wait to take you through this journey to understand more about the animals and the life forms that once existed here as well. So I'm just going to hide the floating meeting panel controls, and we're going to go from here. I'd like to formally acknowledge the traditional owners of the land from which I speak, of the Wurundjeri people of the Kulin Nation, and their leaders past and present, and that the land itself was never ceded. First and foremost, I think it's really important to understand what paleontology is, and it is a unique discipline that integrates geology, biology, anatomy, chemistry, and a whole bunch of really weird things, because what we're looking at when it comes to understanding vertebrate paleontology are animals that may not have any living descendants whatsoever. The creature to the right of the human skull that you can see there is called Diprotodon opatum, the largest marsupial that ever existed, at about the same size as a hippo, at more than 2.8 metric tons. But paleontology isn't just about studying vertebrates, it's every single aspect of the past, from the algae that grew and the stromatolites over 4 billion years ago to everything in between. It is the study of evolution, how life has changed over time in respect to its environment. And again, it's not just about dinosaurs. People think paleontology is only about that, but it's such a broad spectrum. It's incredible. For me, it's about rationalizing and understanding mass extinction events. When we think about the one that wiped out the dinosaurs 66 million years ago, it's comparable, almost comparable, to the extinction event that we face today. And it's important to recognize that. It is a collaborative effort amongst a number of different groups of people. So I'm not a good geologist, or I'm terrible at chemistry, but luckily I know a number of people who really are very good at those disciplines that can help me understand my own science. It's also about understanding what is needed to name a new species. So forward-facing teeth, Diprotodon in the right-hand side there, was a new species that was described by Sir Richard Owen in the late 1800s, and it completely captivated the European hierarchy when they first discovered its bones and were bringing them over to the UK. Australia 65 to 45,000 years ago is a pretty odd place, and this probably extends as far back as 100,000 years as well. It was connected to Papua New Guinea and even Tasmania, and made this gigantic continent made up of called Sahul. The ice ages were raging at this time, with prolonged glaciations in other areas of the world. Australia was starting to dry out at about 50,000 years ago. This period of drying first probably affected the continent at about 350,000 years ago. But it's also important to acknowledge that glaciers were still in mainland Australia along the alpine regions of the Great Dividing Range up until about 20,000 years ago, which is just mind-blowing to even consider. So what have we found in some of the localities in and around Port Phillip Bay that gives us a better understanding of what once lived here? In order to get the most thorough picture of this, one locality we've got to go to is the Mornington Peninsula, particularly the back beaches of Sorrento and Gunnamatta. It's a good question as to just how old they represent. They could represent something between 500,000 to maybe even 50,000 years of age, but it's really difficult to constrain age when you don't have anything to date it against. It's a coastal exposure, and the fossil material itself is very rare. And if after looking at this presentation you think to yourself, I'm going to go down to Sorrento and Gunnamatta, it's incredibly dangerous to do so. And most of the access that's available there is only through a very steep rocky cliff. And it's also located in a marine national park as well. So be aware that you can't dig anything out whatsoever from any marine national park. But at this stage, this area that we think of as modern day Sorrento and Gunnamatta is very firmly inland too. And one such animal that's been found from these fossil deposits was first discovered in 2012 called Zygomaturus trilobus. It was a bizarre, pug-faced like marsupial, distantly related to that of Diprotodon opatum, but it was whack. More than half a metric ton, 2.5 meters in length. It was widely distributed across both Australia and Tasmania. It didn't make it into Papua New Guinea, unfortunately. It had a similar build to a pygmy hippopotamus. So the next time you go to the Melbourne Zoo and you look at the pygmy hippo, think of Zygomaturus. But was it semi-aquatic? It's a good question. We're not entirely sure. And the specimen that we know of from this region, you can see it in the image to the lower right there. Over 2/3 of the skeleton were retrieved after an arc actually collapsed in 2012 and was only accessible after this rockfall. The really intriguing thing for me is that there's this bizarre tiny little mark left on the pelvic region. We don't know what left them. We suspect it's got something to do with predation. As for Zygomaturus trilobus as a whole, it probably survived up until about 30 to 40,000 years ago. We suspect it probably lived on in Tasmania just a little bit longer than the rest of the megafauna. But again, it was a spectacular animal, the likes of which that we do not have today. There's also another animal called Cymostenurus occidentalis. This was a group of kangaroos known as the short-faced or stenurine kangaroos. They got to pretty robust weight, even bigger than me, about 100 kilograms, but some of their distant cousins probably got to more than about the size of a gorilla, 230 kilograms in weight. So it was a generalist herbivore. We know that from its dental complexity. It had very human-like teeth in terms of its molars, which is really weird. And just like Zygomaturus as well, it had something called a brachycephalic skull. Its face was very much pushed in when you consider it against modern kangaroos today. In terms of the recent discoveries, we went to Gunnamatta Back Beach just recently, just last year, and I found the associated skeleton of a large macropod, a large kangaroo, and we suspect that it probably is a stenurine like that of Cymostenurus. All these elements that you can see in the image just here represent different parts of the skeleton, from teeth to incisors to leg bones, that were found scattered over a 2-meter area in this region. Another block that we also found on the exact same day as well was another skeleton of what we suspect is another stenurine, probably Cymostenurus. Unfortunately, none of the skull was preserved, so it makes it really tricky to nail down exactly what species it is, but based on the elements that were preserved and the size of the ribs and the vertebrae and the leg bones, it's probably coming from something like Cymostenurus. Another really intriguing area to better understand the late Pleistocene locality of Port Phillip Bay throughout this time is Lancefield. And Lancefield is an amazing spot, probably one of the highest aggregates of fossil megafauna on the continent. I had the opportunity to go on a dig there in 2016, and what you're presented with is just bone piled up on bone in every direction. It probably represents a water hole and the series of animals coming to this water hole throughout drought and then dying en masse on top of each other, aggregating those bones over the top. It is still very firmly inland when we consider it against other localities, though, in Sahul, and the age is hard to determine. It's probably between that 40 to 80,000 year old age. So what do we find? We find the chonky boy itself, Diprotodon opatum, 2.8 metric tons in weight, named for its forward-facing teeth. Those incisors were massive. They were the size of bananas and sharpened like chisel blades, and they were probably used to eat fibrous food like salt bushes, but they were incredibly important in the landscape. They were more than likely just as numerous as what kangaroos are today. When they disappeared, the last of their lineage also followed them as well. These are some of the fossils that have been taken from the swamp itself in Lancefield, and it really doesn't do justice. There's so much more than just these lower jaw segments that you can see. One of them is still on display at the Melbourne Museum to this very day that you can go see, the jaw located to the bottom of the image. But one of my absolute favorite creatures has also been discovered from the fossil site. When it comes to carnivores, you're not expecting to find them in any high quantity in any fossil locality because there's probably just not as many compared to the herbivores that are dying en masse during those drought periods. But Thylacoleo is something special. It is an extraordinary predator. It is literally a drop bear of death. And a look at those thumb claws, perfect for piercing its prey. Many reconstructions of this animal have it similar to a niche like that of a leopard, possibly even an arboreal species climbing to the top of the trees, falling down on top of its prey, using its heavy mass to subdue it, and using bolt cutter-like teeth and stabbing incisors to do the rest of the work. There is nothing that has ever lived quite like Thylacoleo. So how big did it get? That in itself is a contentious debate. Is it 80 kilos? Is it 130 kilos in weight? It's hard to say. When the first remains were brought over to the UK for Sir Richard Owen to look for, who named the species Thylacoleo carnifex, he hypothesized that this animal, rather than being a carnivore, was a melon eater. He was very wrong, of course. It's not a melon eater whatsoever, but that really weird carnassial tooth that's very pronounced in the lower jaw that you can see there is just not found in any other dental complexities of other carnivorous animals. So this group of animals probably first appeared in the late Oligocene at about 25 million years ago, based on the available fossil evidence. They were the size of a possum when they were first found in the fossil record, and they reached their absolute largest size at about 2 million years ago and up until the absolute latest Pleistocene. And they were also found on Tasmania as well. And this is some of the only evidence we have from them from Lancefield, that single P3 molar that you can see at the top there, and a couple of bite marks on the ribs of kangaroos. But that's about it. And then something happened 40 to 50,000 years ago, something absolutely catastrophic, and we don't really understand exactly what was going on at that time. Probably 85 to 90% of the known megafauna went extinct in the blink of a geological eye. It included the likes of Thylacoleo and the giant marsupials such as Diprotodon, Procoptodon, probably one of the largest kangaroos at the time that got to the size of a gorilla, Genyornis, the demon duck of doom running into the distance there, and Megalania, probably the largest land lizard that ever existed, probably 3 times the size of a modern Komodo dragon. So what was it that kind of led to this mass extinction event? Well, in order to understand it, unfortunately, there are major limitations for what we can understand in the fossil record itself. When it comes to carbon dating, it's right at the very edge of what we can actually date when it comes to the Australian megafaunal extinction event. So it makes it really hard. Most of the sites have been lost due to rising sea levels as well, because as you can imagine, the prehistoric coastline was way out and is almost 10, 20, 30, maybe even 100 meters of water underneath it. But standardizing the reliability of these ages makes it really difficult because people use not just carbon, but other ways of trying to also date and limit what we know of the fossils at that time. It makes it really tricky. So there are major limitations for what we know of the extinction and exactly when this happened in Australia. So what killed off 85% of the Australian megafauna? Was it extreme climate change? We know that over the last 450,000 years, the continents of Sahul became more variable and arid. There were pulses of extinction events that may have happened as well over several glacial cycles. When we look at the isotope analysis of many of the Thylacoleo teeth as well, it was determined that it was hunting primarily in forests. It could have been the victim of these mass periods of drought as they created open habitats. And it's probably part of the answer, undoubtedly so. The climate has to be part of it, but it's not all of it as well. The cycle from about 40 to 50,000 years ago isn't as intense as what it may have been, maybe even 400,000 years ago. So what else was going on at this time? There's this fabulous theory that suggests overkill, and on other continents, when you see humans arrive for the very first time, you can be almost certain that the megafauna will also go extinct with them as well. You can say the same for Europe. You can say the same for North America, South America as well. Humans are incredibly good at killing things. And like I said, involved in the extinction of numerous megafauna worldwide. The issue is that we just do not find any evidence in Australia at all. One of the only thought of interactions between humans and megafauna is from a diprotodontid tooth from Spring Creek that you can see on the right. But when it was reanalyzed only recently, they were found to be trace marks from a scavenging eastern quoll rather than a human actually leaving the nick marks. So there's almost nothing there to suggest the overlap of the two. It's been suggested that the first peoples came to Sahul between 65 and 50,000 years ago, but that is most likely going to be pushed further and further back with new evidence that's discovered. It's here that it's really important for me to say that the fossil record is really incomplete. We don't have much. And even if there was any evidence that we'd had, we need a really large archaeological sample to find that in the fossil record, period. The third one concerns fire. There are many Australian plants that share a relationship with the chemicals in smoke. Did the backburning techniques of the first Australians change up the ecological regime so much that the megafauna went extinct? Well, there was one study that looked at the dental morphology of the giant kangaroo Procoptodon goliath, the one the size of a gorilla, and it showed that it had a pretty tough diet. It was probably eating chenopod's, which are saltbushes, which are still widespread throughout southeastern Australia today. So unfortunately, we can't be certain of anything, which sounds about right for any paleontologist in any paper you ever read. We don't have enough evidence. We need to go out and find even more. But throughout this time, there were also other survivors as well. Thylacines and Tasmanian devils survived the mass extinction event of the Pleistocene and only went extinct at about 2007, maybe even 2,000 years ago. Thylacines themselves were probably much bigger than the ones that were found in Tasmania. And there's this fantastic specimen that's been found on the Nullarbor, which is completely mummified and more than 4,000 years old. We've also found evidence of them in Port Phillip Bay. Now, the cause for their extinction is really intriguing. We don't exactly know why they died off. I suspect disease is probably involved, especially as dingoes came across for the very first time onto the continent at about 8,000 years ago, but we have no idea what that disease would have even looked like. The history of Port Phillip Bay is such a fascinating topic, and I'm sure it's going to be talked about for an awful lot after me as well, but it only formed relatively recently. The ages as to when this formed are still heavily debated. We're not entirely sure. It's even suspected that the Bunurong may have actually witnessed this flooding event and talk about it in the time of chaos. The three major tributaries of the Werribee, the Yarra, and the Paterson River basically intertwined and make the current indentation at the heads that we can see today. So really hard to say exactly when this occurred though. But what were some of the animals that were living in and around this time? There were dugongs, which are very alien from anything you would expect to see in Port Phillip Bay today. They're denoted in the presence of one single rib. But luckily for dugongs, they have something called pachyosteosclerotic bones in their ribs, which means that their bones, when you cut through the ribs in the cross-section, they look like ivory. They're incredibly dense. So we know that they were there. Was this just a single individual that somehow accidentally got there? This was probably dredged in the 1970s and discovered and was then reported on shortly thereafter. So a bit contentious, but there were probably dugongs at about 10,000 years ago, at least on the edge of the previous Port Phillip Bay. And then, of course, we come into the European extinction event, and it's super important to note that over 100 Australian unique flora and fauna have been exterminated since 1800. It is comparable to the extinction event that wiped out the dinosaurs 66 million years ago. And the thylacine, of course, in Tasmania was one of those perfect analogues of the European extinction event. We are heavily implicated in their extinction. The reason for the extinction of many local animals and the local extinctions of, say, fat-tailed dunnarts in many regions across Victoria today is simply because of habitat loss. But there's also invasive species and the role that climate change has to play, and agriculture as well. Every single Australian ecosystem that you see has been infiltrated by weeds. There is no pre-European Australian ecosystem, which is incredibly sad to think. And it brings me to a species that I absolutely adore talking about. The grey nurse shark is one of these species that only recently went extinct. And in another talk, I talk about how this animal had been around in excess of more than 30 million years. We can find their fossils dating back on the surf coast in 30-million-year-old deposits. They have these incredibly beautiful needle-sharp teeth projecting from the front of their jaws, and they're magnificent predators as well. Unfortunately, with the advent of snorkeling and scuba gear, people were scared of sharks. And without doing the proper research required to understand more about their anatomy, people went out there, particularly those of European ancestry, and killed every single last grey nurse shark in Port Phillip Bay, and to the point where they're basically functionally extinct in Victoria. And you might raise your hand and say, well, aren't they still there in Malakuta? Yes, you might get the odd individual coming across the border everywhere now and then, but we don't have any population that is capable of breeding and self-breeding within the state of Victoria that I'm aware of, to the very least. So it's an incredibly sad story because it's such a fascinating creature. It practices something called intrauterine cannibalism, in which the mother has 6 or 7 pups in the uterus when it starts off in life, but one of those pups will wake up above all others and then just start eating its brothers and sisters, which is quite disgusting. So we still have populations of them in New South Wales and Queensland as well, but there's about 1,200 individuals on the eastern seaboard that are left. And you might be asking, well, can't we bring them back if they're still alive today? Because of that intrauterine cannibalism, we're most likely not going to see any evidence of them coming back. It takes the female between 2 and 3 years to recover from a single birth. But recently I've been doing some fascinating work on eastern quolls and trying to understand their hyperabundance. Now, there are 2 different types of quolls. There's the tiger quolls, which can reach about 7 kilograms in weight and can rival even the largest feral cats. Eastern quolls are significantly smaller. They get to just over 1 kilogram in weight. But unfortunately, the mainland population of eastern quolls, they still survive in Tasmania today, went completely extinct in around the 1960s. So they were persecuted by European farmers, shot in their tens of thousands. We know that foxes would have had a huge effect on them as well. But there's been some more evidence recently to suggest that maybe disease was also to blame, some kind of distemper-like disease that's currently found amongst canines worldwide. What is so fascinating about the eastern quoll in particular is evidence of hyperabundance just prior to 1860. And I've got these quotes on the screen just here. In 1944, a column in the Portland Guardian reported in the 1870s, there was a plague of them, similar to present-day mouse plagues, which swept over the country. They were in thousands and spent the day in hollow logs under our buildings or anywhere they could get shelter. Under fowls not securely shut up were soon mopped up, and they must have taken a tremendous toll of ground birds, which were far more numerous than they are now. But every single report is like this huge hyperabundance of them coming in through towns. Another anonymous observer in the 1900s said, probably not a year passed, but some adventurous man or boy tried to turn rabbits and breed them, but they were all met with the same fate, extermination by the native cat. Did they actually hold the rabbit to account in some areas before they went extinct themselves? There's a sporting magazine that reports more than 600 native cats being shot in 1866. In one night near Wando Vale, 600 may have been shot. It's crazy to think that they were here, and now that they're locally extinct. And it brings the question as well. And before we get to that question, I just wanted to show you this footage of a tiger quoll that was rediscovered in the Grampians just recently. And if it doesn't make you want to hum the Jurassic Park theme tune, I don't know what will. Look at the muscular build of this magnificent marsupial carnivore, the largest on the mainland that currently exists after the devils and the thylacines went extinct over 2,000 years ago. Turns out that individual was actually from a captive breeding facility and had accidentally escaped out into Gary World, which is the Grampians today. But should we bring them back? Should we bring back the eastern quoll where they were once hyper abundant? And of course, you know the answer to that. Hell yeah. We should try our best to bring them back. And of course, Mount Rothwell is one of those places where you can actually go and see them and where they are trying to breed them and getting a population high enough so that they may one day return back into the modern environment. So I don't know if you've ever been to Mount Rothwell or if you've ever had the opportunity to go into a night safari, but I had the opportunity last year to go and see it, and it felt like pre-Pleistocene Victoria walking around at night. And you can go and book a session and go during the night, and it really is one of those most amazing things, and it really makes you realize just what we've lost in a very short period of time because of European occupation as well. That's the end of my slides. Thank you for listening. We won't take questions right now because I believe we're taking them right at the end. I'm going to pass it back to Shannon or whoever else is ready to take on board.
Yeah, look, thanks, Ben. Absolutely intriguing. Looking forward to some questions at the end there. So if that's stimulated some neurons, please jump into the Q&A and throw out a question to Ben. Now, you're going to get the opportunity to meet Professor David Kennedy, a distinguished coastal geomorphologist hailing from the University of Melbourne. And I tell a little anecdote that when we started looking for a geomorphologist to present tonight, I went to about 6 different sources, and all of them put David up as the number one person to cover the topic today. So with over 2 decades of dedicated experience, he's a renowned expert in the intricate relationship between climate change, storms and sea level rise, and their impact on coastal landforms. For the past 10 years, Professor Kennedy has been a cornerstone of the University of Melbourne's academic community, diligently researching the Victorian coast. Notably, he played a pivotal role in co-leading the award-winning Victorian Coastal Monitoring Program, the esteemed Eureka Prize, earning the Eureka Prize. In his upcoming presentation, Professor Kennedy will provide a unique perspective on the Bay's history, employing his expertise in geomorphology. He will weave together the most recent research data on beach dynamics and bay infill, shedding light on how these factors will influence the response of our coast to the ever-pressing challenges of population growth and climate change. Get ready to delve into the fascinating world of coastal evolution and preservation with this distinguished scholar. So over to you, David.
Thank you very much, Paul. That was a wonderful introduction. Thank you. I'll just get through. Let's share my screen.
We have movement. Yeah.
Yep, we've got it now. Excellent. On the second side of the go. Right. Well, thank you very much, everybody, for joining us all on a Wednesday evening. What I thought I'd do today is, it's really interesting when we think about the Port Phillip Bay, and I should actually start off by also acknowledging very much my co-workers here, the Victorian Coastal Monitoring Program, which Paul very nicely we won the Eureka Award. Maybe some of our great citizen scientists are in the audience today. But very much my colleague Dan Iridai-Konu from Deakin University. And we've been working very closely, especially on Deakin's vessel here, the Yola, which we've actually been collecting a lot of data recently along the bay in the environment here. So what I thought I'd do today is actually show you a whole lot of raw data and really show some of the research we're actually doing at the moment and really seeing some of the development of the knowledge that we're actually saying within the bay. Because it's really interesting when we look at the bay from a broad perspective, we can say how it's developed, but then when you ask for specific evidence, it's amazing how little studied the bay is. So what we've been doing recently is really working collaboratively with communities, government, and really a lot of the projects has been looking at how do we have the evolution of the bay today? What does that mean? But also how does that influence our dynamics for into the future? And I think that's really a critical part of the past is the key to the present, but also what is it going to be in the future in a very much a warming world? And what we've been doing is doing a series of new developments and deployments right through, even if you can make out the little yellow buoy in the distance is one of our wave buoys we've put out right through the bay. And really what we've been seeing is really, what do we see when we're in Port Phillip Bay? Second. Aha. So what do we have when we're looking at, what do we mean when we think of Port Phillip Bay, when we think of the environment? And we're very much looking at often the visualization. Here we are at St Kilda. We're looking at beautiful sandy beaches in the space. I mean, obviously taken on a nice day, with the bay heading out towards the CBD sitting in the background. And this is really the environment that most people think of, and coastal managers are really keen to keep as sort of a key asset, I suppose, within the environment, but also the key buffer between the ocean sitting out here and the land sitting on the other side. And that's the way to think about the beaches, as a movable buffer, as well as it's effectively the land's bumper bar for the marine environment. So we have St Kilda Beach. We move right round onto the Mornington Peninsula, down at Dromana. We're looking at similar beach environments, but in the case here, we have our beach houses, beach boxes. We also have small dunes developing along behind. No dunes at St Kilda anymore, but we do have dunes at Dromana. We look in other parts of the bay and we bring ourselves down to Sandringham. We start to change our geomorphic environment. And these might be some of the things Ben likes. We've got eroding rocky coastlines, but we have a system here where we have both beaches and rocky coast and shore platforms, potentially evidence of higher sea level sitting in this space, but still containing beaches. Or we go right across to the western side of the bay, and we're down round Point Wilson. We're coming up towards the Werribee treatment plant. We're looking at an area that's much more rocky. We have saltbush, which our diprotodons and those things we're enjoying muching away. We have that sitting on the coastline, but very much fronting a coastal system that's dominated by basalt. We've got old lava flows here. These are millions of years ago. There's active lava flowing into the bay in this section, and then shells deposited on top. So our natural environment is incredibly variable. We've got different types of beaches. We've got eroding coasts. We've got old basalt plains and much more muddy environments and sediments. But of course, once we put the human element on it, and we're down here in, this is down at Black Rock Yacht Club, or harbour, whatever they call it, we don't actually have anything natural left in that space. And we look in other parts of the bay too. We're down at the historic seawall. We don't really do seawalls like this anymore, quite luckily. Well, at least not in Victoria. But we also have major infrastructure, the Spirit of Tasmania terminal at Geelong. So this is my one stolen photo. This is from the ports of Geelong. And down lighthouses and seawalls down here. And this is further down at St Kilda as well. But it's quite a challenge when we look at our environment of what do we see as being the natural functioning as opposed to the infrastructure we have. And as a coastal geomorphologist, it's really one of those frustrations you have professionally, is when people often talk about saving the coast or saving the beach, they're often talking about saving a line on a map rather than actually the beach as a landform. But what we're looking for that is really what we want to maintain is, well, how do beaches get there in the first place? How do they evolve? And once we know that, how can we keep them functioning into the future, at least as best as we can? And I think that's a really important part. So when we think of Port Phillip Bay, we've got the beaches, we've got the harbours. That's one way to look at it. As a geomorphologist, we tend to look at it more in this space. And what I've got here is a digital surface model. So this is the latest elevation model right round for Port Phillip Bay. We've got, here's Sorrento, we've got the Mornington Peninsula. There's the Bellarine. I'm coming around the edge of the Bellarine here. And we can even see shipping channels. There's a shipping channel coming into Geelong, that line there, and a shipping channel coming out down into the Yarra. So once we start looking at the bay, our beaches start off as being a thin veneer right round the side of a much more extensive and complex environment. And to give an idea of that complexity, if we just do a cross-section coming right through the heads, and that's what we're doing in here. I'm not quite sure, the distance has gone a bit wonky on my graph. As I said, I'm showing a lot of raw data here tonight. But as we move through the heads, we actually go down in the canyons, which are extending down almost to about 100 metres water depth within the canyons at the front of Port Phillip Heads. We come across the Great Sands, that comes up pretty much to sea level in a lot of locations. We move off the Great Sands. We then come into the centre of the bay, which is around about, on average, 20 metres water depth. And this starts to become very important into what types of sediments we see there, but also where do pollutants go? What happens as we bring material in? Because what an estuary is, which is what we have in Port Phillip Bay, it's a basin that just passively accepts sediment that all flows in. So all that stuff that goes down the drain, especially in stormwater events, will end up in the bay and is settling in the centre. But critically, it's that depth. It's quite a shallow, relatively shallow environment when we start comparing this to other basins worldwide. But in terms of its evolution, we're really looking at a system here that's actually known as a sunk land. So what we have over geological timescales, and we're doing tens to hundreds of billions of years, Port Phillip Bay is actually what we call a structural basin. It's actually a graben. We have major fault systems which have actually shifted, and the bay itself has fallen down in the middle of what is lined fault systems along the side of the bay. And after that's occurred, that's then started filling in over the scales of hundreds of tens of millions of years within this space. But when we're looking at the modern environment, we're really starting to look at what has sea level been doing. So what I've got here is our elevation to current mean sea level, 0 down to minus 120 metres, and we have the age coming along in this space here. And the red and the blue lines are different models and different data for where sea level has been. Surprisingly, I always find it surprising anyway, we actually don't have a good handle of higher sea levels in Victoria. It's amazing how little information we know when you get down to specifics in that space. But what we do know, this is known as the last interglacial period, 125,000 years ago, sea level was 3 to 5 metres higher than present. The next most recent is during the last 6,000 years, 6 to 7,000 years, sea level was 1 to 2 metres above present levels. So what we can know from the past higher sea levels was, first, in a warming world, is sea level can go higher. It's no problem for nature to rack up sea level to 5, even 7 metres in places. And what we do know from this sea level curve is, here's a glacial period. This is the peak of the last ice age. Around 23,000 years, sea level was almost 120 metres below present. There's a warmer period. As we move from a warm interglacial to a cool glacial, the climate tends to cool relatively slowly. But what we know from historic evidence globally, and we're starting to build this picture up in Victoria, climate likes to warm, and it likes to warm quickly. And we're looking rates here on average 15 millimetres per year is what we're seeing. And when we link into ice sheet collapse, there's suggestions that sea level may have jumped metres in human lifespans. So you can imagine yourself sitting in here, oops, going the wrong way. Here we are in Port Phillip Bay. 23,000 years ago, it was completely dry. In fact, if we take that average depth at minus 20 metres, we come along that area, it's been dry for a long, long time. Last time there was any water in it, probably just came in about 80,000 years ago. That's the end of the last interglacial, and it was a lot deeper, 125. So if we take the level of human migration into the Australian continent, which was what Ben was very nicely talking about, we have people coming into Port Phillip Bay in about this stage. So 60,000 years ago, it was dry. There were rivers flowing through it, and in fact, I'll show you can see a bit of a river coming through in the bathymetry in that space. These canyons are a product of these lower sea levels. So people would have come in here 60, 40,000 years ago, would have been a beautiful flat plain coming out. You can imagine driving down to Geelong with that flat, well, what was before suburbs, but the flat grassy plain. That's what Port Phillip Bay would have looked like. Sea level then rose really quickly. The people would have observed it flooding in through this section, especially at these levels, this elevation, about 20 metres. This would come across at about, this is the stage where we're looking at major ice sheet collapse. And this is where these steps in sea level come. So a lot of the legends we hear, I mean, it's a commonality of humanity is a great flood story, which goes all across all cultures, is what we're actually seeing is the sea level rise from the last ice age, which they said occurs on human timescales. People would have observed, well, my grandfather could walk across there, now it's underwater. It's an amazing scale to actually see that. So if we start zooming in on different areas, so we're just taking that same imagery, we're coming into a deeper, a more higher resolution. We're right in the middle. Here's that canyons coming right through the front of Port Phillip Heads, down to over 100 metres. Well, 99.22 to be exact, metres right in the front. And this is where we've been doing with the surveying with the Yola and with other image areas, as this is some of the latest high resolution bathymetry we have for Port Phillip Bay. But we can see the canyons featuring through this space. We can see where the river channel was actually coming along there. We can see that imprint. But the great sands have then come in and moved across, and that is then feeding sand onto our beaches on either side. And importantly for the great sands, if we just jump back in terms of ages, the age of the Mornington Peninsula starts to, some of those sands start to be, the youngest end start to be around 120,000 years ago and older. Once we start pushing ourselves back in geological time, we start actually removing major features that we actually have. We actually make Port Phillip Bay more open, but we're multiple sea level cycles away. If we move over to the western side of the bay, so this is round towards the Western Treatment Plant area, that side, we can see there's one of these old channels coming out, probably from the Werribee River and those ones, coming out, cutting its way through the seafloor in that space, and then small channels moving down along the side. This imprint that we have from past lower sea levels, the rivers were cutting down through them, cutting through those features. And interestingly, from these, there are some very enigmatic small circular basins, which have really only come up in our recent surveying, which have got a lot more high resolution than this as well, but potentially old volcanic craters. We go across to Western Victoria, the Colac region in that space, we've got a lot of old bar lakes in that space. We probably have a lot of these in Port Phillip Bay as well, underneath that area. And this big lump here is actually all the dredge spoil from the shipping channels. We've got the big human imprint coming across with the shipping channel all the way there, and that's that dredge spoil. Some of the older dredge spoil there, also from the dredging of the Yarra, and their new bund walls they're putting in for the newer ones in that space. But if we shift over to the eastern side of the bay, so here we are at Sandringham. This is Red Bluff, Sandringham Harbour, back down here at Half Moon Bay, in that space there. We get quite a different geology as well. We get different rock types that are there, but also the rocks are underwater. Our beaches are really a veneer on top of a lot of rock in that sand. So our different types of environments mean we get very different behaviours of our coastal system and different management. In the case here, this little blip we can see here right where my cursor is, that's the wreck of the Kerberos. So that's the Kerberos put there in the early 1900s as a breakwall. And we have here a dredge hole, or often known as a borrow pit, which I always finds interesting. No one ever puts the sand back into a borrow pit, but used then for beach re-nourishment in that space along there. So what we're really seeing then is what we're looking at with them, and this is what's been looking at with a lot of the reason for a lot of the project, is there's a geomorphic interest, but the government, well, DECA to be exact, really wants to know is, well, where is the sand? A lot of our beaches are maintained by beach re-nourishment, but is that a viable option for the future? And if it is, where do we get the sand from? Because sand, when you find globally, is becoming more a valuable resource. So what we've then looked at for the bay as part of the mapping program, we've got the high resolution bathymetry and just a map here of then superimposing new sediment size sampling we've done across it. And you might say, well, what's the mud? We know the bay's muddy. But interestingly, the size fraction determines where your pollutants go. It determines whether they're bonded into the sediment or they're free to be absorbed by things such as fish. But also, until we did this sampling earlier this year, the last sampling of grain size in Port Phillip Bay was in the 1960s. And it's a really interesting thing, at least from a scientific, but also a practical management viewpoint of saying, we don't often have a lot of the basic data of what's even there. So once we start looking at our grain size, we have our mean particle grain size along this guys. These are known as phi units. They're negative log to the base 2 of your grain size in millimeters. But don't worry, if it's 4 phi, it's mud. If it's over here, this is sand. So we've got sand down into the yellows and reds in that space. And we can start to see our distribution. But I'll simplify it down to just sand and mud. It's a nicer way to look at it, especially if you're doing renourishment. You want to know where the sand is. So what we've found is the centre of the bay, well, what we've confirmed and extended, I should say, is incredibly muddy, 100% mud in that space. But importantly within this, that sediment-water interface is pretty much a new discovery we've done within the program. It's not a solid face. It's almost like cotton wool, and it's incredibly hard to sample. But it really is unknown how this allows pollutant loads, because some of the work we've been doing in association with Fathom Pacific and ADE Industries is there's quite significant accumulations of PFAS, those forever chemicals in the firefighting foam, in the centre of the bay. And how they're behaving is really an ongoing project within that. But we can see that space. So where we've got, here's our old river channels. We can see the imprint of the last glacial. Incising of those rivers is imprinted on our modern sediment size. I can actually see it. There's the Yarra coming out through there. Here's our other rivers coming in from the west in that space, and then even coming out towards where the heads are in that channel. So just a smaller zoom in. And once we start looking within these areas, we start to go, well, how much sediment is actually there? How much is it depositing? How much is accumulating? Because that's really critical for what we see with how our sediments then behave in the future, how they accumulate areas. And this is some, again, very raw data, as in I was down in Warrnambool on Thursday and we're analysing this material, so literally it's hot off the press. But what we're simply looking at here, it's a sub-bottom profiler, and all these blurry lines is what we're tracking is, I'll just go back actually, I'll show you where we're going first. We're running through one of these channels. So this is the old river channel coming down. We can see other channels coming out into the centre of the bay. We really want to see, well, what's actually there, how much is accumulating, because that gives an idea of where everything's going. And we have, I can interpret, we've got basalt along this area, and we're dropping down in this space, and we're getting larger. So our sediments here are coming up in that space. I'm presuming you can see my cursor, and we're looking at the basalt coming up a lot further. So what we're really finding, and here we really see very nicely, is this very nice sequence. And we don't know how old these sediments are, but what we're looking at probably is 2 to 3 millimetres at least of sediment accumulation per year in Port Phillip Bay through time. And while that doesn't really affect us too much today, really this top bit is the stuff that's important. These are key, what we'd call paleo archives. These are key geological evidence for tracking what has climate done in the past, what is it going to do in the future, how does it behave during warm periods, but also what's happening with our megafauna around. A little interesting side one, if we go across the spoil heap, so across here, we actually find it tends to, something's within that material actually zeroes out the signal. So we're even having an impact with our modern human activities on geological surveying along this area. Lots of thick mud, and this is important in terms of what's here, because this affects how the material will behave into the future. So what we then need to do is say, well, once we've identified where the material is, how old it is, where's it going, is then what's occurring with our wind environment. How is this distributed? How does it affect where our beaches are? And this is some modelling done by Huey Tran, who was part of his PhD in engineering at Melbourne, of the wind regime in Port Phillip. But the key really aspect of this is we really find that we're quite seasonal in where we are. As my 10-year-old daughter criticised me when I showed it to her after school today, summer does not go from October to March, but we've just divided the year into 2 parts. But we find there's quite a distinct difference in our wind direction from more southerly winds in summer with a more northerly component in winter. And that's quite important when we start affecting where our sand's going to go. But what we do with our storms, because the wind is very important, because Port Phillip Bay is what we call a fetch-limited environment. The winds determine the storms, which determine the waves. Very little swell gets across the Great Sands because it's so shallow. And this is a modelling of storm tide height. So we can get up to just over 1 metre along the eastern side of the bay. In terms of maximum storm wave height, so this is sort of our big events here, we're estimating sometimes up to 2 metres along the eastern side from those westerly winds. And this is really critical because our areas are quite low. We can bring the sea level up. Well, imagine you have high tide, spring tide, 1 metre storm surge, then your waves are on top. That's when we get our flooding events. So what we've done as part of the program is then installed right through the bay, and this is definitely very much the Deakin crew down at Deakin. There's now a wave buoy network, which has now been going for about 3 years. Really this is the first time we've had continual wave measurements in Port Phillip Bay. And I've got the web address there, vicwaves.com.au. This is the live data from yesterday when I took a screenshot. We're actually getting some spikes in sea surface temperature. We've just added temperature loggers onto those buoys as well. So you can jump onto that website, and it's actually now a buoy network right across Victoria. But the reason this is installed is really saying how our beach is going to respond. So what I'm just going to quickly do, just keeping an eye on time, probably another 5 minutes for the last part, is say, how do we link all this in for what are our beaches doing? Where are they going? And the critical part when we think of a beach is the beach extends from the bit you walk on, that's up here. It extends offshore down to wave base. So it's extending down to, in Port Phillip Bay, 5 to 10 metres underwater is your active profile. What you're walking on is a store of sand for the next storm. So what we know beaches will do under a higher sea level, which is what we're going into, plus a storm, is the beaches want to flatten out. That's how they respond. They take that sand that's sitting on the front of the beach here, throw it into the surf zone, flattens it out, decreases the energy. So the net movement of, the shoreline moves inland, the net movement of sand is offshore. The alternate model is where you've got space, is sea level rises up, the beach itself resets inland, and sand moves inland. Two fundamental differently responses. But the key part for our bay is we remember back to those early pictures. In some areas, we have dunes. We go along the Frankston coast. Our beaches may tend to go more this way because there's space. Where we have more rocky areas, more of that sand's going to go offshore. So it means you've got to start moving sand if you want to keep the beach in the same spot from different areas. But also by putting in a seawall, you can actually force the system out of its natural response. Because beaches want to flatten. They're loose piles of sand. That's how they work. They absorb that energy. They're the energy buffer. They absorb it, and that's why they're there, and they move. So I'm just going to jump out of Port Phillip Bay, go all the way up the New South Wales coast. And the main reason for that is the critical part from beaches. If you want to take one thing out of this talk, is beaches are incredibly dynamic, and I like to think they're like a dog's tail. They're just constantly wagging, and we see them at different points. And this is just a movement of profiles. This is all natural. And that blur is just our movement of our beaches from Maria Beach. And this is, I would say, the best survey record in the world, done by Roger McLean, based at the UNSW Canberra, Australian Defence Force Academy. And they've surveyed that beach continually for now 50 years. 50 years of continual surveying of that beach. And what we're seeing here is just different storm events. Summer, winter, small storms, big storms hit the East Coast, major erosion event in the early 1970s. And we see this area going along. The critical part here is if they'd built a seawall in that spot at that time, we may not have seen that sand come back. It's fundamental when looking at beaches to say, what is the natural dynamic? Where's the sand going to go before you do something? Because once something's done, then there might be problems and you might not get back to a natural state. So to look at some data from Sandringham, which has been one of our main focal areas. If you're going down Sandringham, in fact, where this picture's done, in fact, done in collaboration with Paul, with Lifesaving Victoria, we put out some citizen scientist CoastNet stations all the way around Port Phillip Bay, really to monitor the beach. Data from our wave buoy, we see this summer coming from the south, winter, there's more of a northerly component in that space. But we're looking at waves that aren't particularly high, 0.8 metres. It's not compared to the open coast, but it's definitely enough to move the sand. And what we've found, and this is through our citizen science program, started this off through drone surveying, is the sand is sloshing in between along that beach. In winter, it moves south, so it builds up on the northern part of the groins, erodes on the south. In summer, it does the opposite and moves back north, and that's what we're seeing here. So we find in this area that this beach, rather than moving the sand offshore, it's moving it sloshing within that space, and it does it over an entirely Bayment scale. So this sand is constantly moving along that space. That is what it naturally wants to do as the winds change. And if we look at the position of the shoreline through time, so if we take the black line, that's Sandringham Beach, as we actually find there's a lot of happening. So we're just looking at shoreline distance here from a start point, which is a 1930 aerial photo, and time along the x-axis. So these are taken from aerial photos, and then this is taken from more recent satellite survey. But we see it's probably a data issue here, but the beaches started to decline. Then we started to have management occurring on that beach, a period of stabilisation, and then the beaches actually remain quite stable. But that's really occurred post-management intervention, and often management moves things around. So just to compare what's happening in this space, there's a lot of data that's in this area, is we're looking at aerial photos for the last 90 years. If the part of the beach, so we have our middle part of the beach, southern middle, if it's in this phase, it's eroding over that longer time scale. We have the aerial photos, which is post-introduction of groins and renourishment. So if it's in this area, it's accreting more recently. So what we can say from this is actually the management interventions at Sandringham have been quite good. They've actually shifted most of the beach from being an erosional state over 90 years to being accretional. And it's actually a really positive, good news story for the beach system there. The groins and the renourishment have actually been maintaining the beach in their current position, because if they stopped, the sand is going to disappear. But it's not the case for all of our beaches. If we move over to St Leonard's, and this is just some of the team here setting up the drone, part of our surveys, a different beach system, but a beach itself which is more in long-term retreat on its southern part. So on the northern part of it, it's actually accreting a tiny bit. So we're looking at, this is a very long-term shoreline here. So we've got different images is what we're doing. The last 30, well, since 1988, back to 1962, looking at the dune line, back to 1962, looking at the water line. But critically, the dune has actually remained quite stable, but we're seeing retreat within the beach. And this is actually a pattern we do see other parts of the world, is the beach starting to retreat, pushing the coast towards a threshold. But in the case here, it's not sloshing round. They actually renourished this area a couple of years ago, and that's now accreted. So a different management strategy for a different spot, and just showing how much the beach is actually moving for down at St Leonard's with that build out that's actually been there. And I think the key take home message really is in this space is natural systems are incredibly dynamic, but it's where they cross with humans, it's where the problem is. Our beaches will survive. They'll happily move elsewhere. That's why they erode. The sand is needed elsewhere. They'll happily move as sea level moves up and down. The problem occurs is when we have that break between it. And what we often forget is natural systems are variable. They adjust during storms. And then, of course, we have climate change on that space. We know sea level is higher. It can happily go higher and quickly too. But at the same time, I always like to finish off with this, there's another hockey stick curve, which is often forgotten. And this is human population in billions and years, going back to 1050 up to 2050 in that space. Humans at the same time are expanding more and more into the natural zone. Even without climate change, we would still be exposing ourselves to a greater extent to hazards through plonking ourselves more in the coastal zone. And it's more of an issue within areas such as Port Phillip Bay because it appears low energy. And that's really the wicked question we have to go to the future, is now we know we've got the sand, we can plonk it onto the beaches. but how much do we want to keep those beaches there? How much effort's in, and what do we value? Do we value the seawall or do we value the beach? And I'll leave it there with that thought for everyone for an evening.
Thank you so much, David and Ben, for your very wise words there. I know I learnt a lot, and yeah, I have no doubt that everyone in the audience did as well. So from Ben's talk, I know that probably many of us have expanded our vocabulary significantly. I'm probably going to try after this to say Zygomaturus trilobus like 3 times in a row really, really quickly. I probably didn't even get that right. But it was really cool to hear about the demon ducks of doom and the large drop bears that probably a little bit different to those that live today. But it was really fascinating to hear about the salt marsh that obviously was around still back then and still today, and how that's a very similar habitat for some of the creatures despite the years of difference there. So we have firstly a couple of questions for you, and then we'll head over to David. So and also just we are a little bit over time, so everyone in the audience, if you're keen to bear with us, we encourage you to do so, but also understand if you have to make a departure. So Ben, Christine is asking, you mentioned about the local Aboriginal people may have witnessed the filling of Port Phillip Bay, and would this have been as dramatic as for the Mediterranean or more of a gradual flooding?
I think the reference to the Mediterranean is from the late Miocene, when it completely dries out from memory, that reference there, and it becomes a salt kind of platter, which is kind of apt for the Mediterranean platter of food today. David, you're probably really well poised to answer this as well, though. Like you were saying before that, yes, they were witnessing it in a matter of 100 years. The grandfather was pointing over to one area and saying, look, I used to be able to walk over there. So almost certainly it would have been viewed by human occupation.
Yeah, I'd say it probably would have been the idea of, I mean, it's older for the Mediterranean, but it's the idea of a waterfall was coming over the side, I think, is how that's done as the Mediterranean infilled. I'd say for Port Phillip Bay, it would have come up and then would have probably been like a creeping swamp, would be more what I would say would have been a rapid creeping swamp. But that would probably it would have come in, because it's so flat, once it got through the Great Sands area, through the old Yarra channels from that, it would have flooded through that and then spread out. So we would have seen a larger creeping swamp marching up through the bay, would be my thought.
It's also interesting as well just to think about when humans first got to the state of Victoria, because it's different from the top ends. We kind of view Australia as just this one giant mass continent. And when humans got there, they got to every single part of the continent, but that is not the case. It would have taken them tens of thousands of years to reach the other side of Tasmania. I think the oldest evidence of occupation of Victoria is between 30 and 40,000 years from memory. So please quote me if I am wrong with that. I think it's true. I think Gary Word and the landscape in the Grampians, the oldest evidence there is about 22,000 years, but it's undoubtedly probably older than that by a good 10 to 15,000 years of occupation as well.
Great. Thanks, Ben and David. Ben, one more for you. A great question from Robin. Are there any First Nation paintings or stories of animals over 25k old?
Well, there's every single thing is contested. It's like, is it what we think it might be? We're not entirely sure. That's a beautiful thing about paleontology. We can never be absolutely 100% sure, especially when it comes to paintings. I want to share my screen just really quickly in anticipation of this. So we'll go to this one first. These are some purported paintings that you can see here. I'll just get rid of show, hide, float, and meeting controls of Genuornis from the top end of Australia, which was that giant demon duck of doom. But do they represent that? It's just like we've never seen one in the flesh. We have absolutely no idea what they look like. There's no soft tissue that has been left over of these animals that we can kind of interpret and make sense of. It could be, but it might not be just the same. They could just be some kind of rendition of an emu or even a cassowary or something like that, probably an emu. There's also a very contentious debate about what this cave painting represents as well. It has very muscular looking forelimbs. It has the stripes going all the way down the side of it as well. Is this an artistic rendition of Thylacoleo that was seen by the first peoples in the flesh? Don't know. Hard to say. It certainly could be, but the fact that it has the stripes means it could just as easily be a thylacine. And there's very well-known cave paintings of thylacines all throughout the top ends as well. Last one I wanted to end on, though, across the Pacific, there's some really fantastic artwork that was done by early prehistoric humans there. And one of the clear ones that have been created is the one that you can see in the top left-hand corner there. Does it represent a giant ground sloth, or does it represent a giant cave bear with its young that you can see directly underneath it? I think it's a really good example of what a ground sloth might have looked like. And for those of you unaware of what ground sloths were, they got to the size of elephants in the late Pleistocene. Erymatherium probably got to elephant sizes. And they distantly related to modern sloths today. They were so extraordinarily different than what you can find in the modern fauna of South America. So who knows what we'll find in the future as well. There'll undoubtedly be other artwork that comes out of this. And
Great, thank you, Ben. And David, we've got a few questions for you, and I just wanted to say it was just really fascinating to hear your analysis of how the different features can paint a picture for us of what has happened in history. A few things that sort of stood out was how, the evidence of, the presence of cliffs now can be evidence of higher sea levels in the past. How the area cools slowly, or climate cools slowly but warms really quickly. And just the movement of sand and understanding how the different movement patterns and natural cycles and natural systems, and having knowledge of that, really helps to contribute to our knowledge of what to do about certain things, or if it's just something we should actually let do its thing. So a couple of questions here. We've got one from Alyssa is, has there been much research around the impact of increased water depth due to shipping channels on the flora and fauna of the bay?
I haven't seen anything on flora and fauna in that space of the shipping channels. It does seem to be, in terms of closer to in the northern part of the bay as we're going into the Yarra, there would be local influences. There have to be local influences where you're actually dredging, but probably not bay-wide ones in that space. I will preface this as I'm not a biologist. Definitely with the channel widening that they had down on the southern part, and that was very controversial. That does seem to have allowed some more and deflected some of the deep water ocean energy, because that's the one spot where we do get deep water ocean waves into the bay. So the channel deepening has deflected some of that energy towards the shoreline there, and there's been some really and that was where that wave model was actually developed with Huey Tran's modelling there. It was specifically trying to work out what was happening with that. In terms of flora and fauna, I think locally where it is, yes, but probably bay-wide, probably less so, would be my thought.
Great, thank you. And one more from Sarah is, please comment on the impacts of seagrass of beach renewing around the bay.
Oh, now, again, this is into biology. It was actually one of the person who actually did the part of the modelling for our grain size, Ollie Dalby, just finished his PhD actually on seagrass. In that space, there's quite a lot within the seagrass space. It's really, seagrass doesn't like to be disturbed, I think, in those areas. So if you're dredging near and on seagrass, that's obviously going to destroy it in those areas. But there's still, jury, I think, is still on the exact cause of declines, because a lot of the ones as part of, there's a big Port Phillip Bay environmental assessment going on. And in some of the other macroalgae, the large red macroalgae, not the ones that, some of the ones that wash up a bit, they're finding quite big seasonal changes. There's some areas where there was lots, there's not any now. And yeah, it's not real. I wouldn't feel confident saying too much more than that. But it's very seasonally fluctuating. But it's the water quality and the physical disturbance here. So we don't ever want to dredge where there's seagrass. That's not going to be good for it.
Yeah. Great, thank you. And maybe just one quick one more from Christine for you, David, is do we know about the sediment sand circulation around the bay in general rather than at specific sites?
Yeah, we're actually getting a much better handle on that there. I just chose a couple of just contrasting ones there just to give a bit of an idea. We've actually, part of the team we're doing has got some longshore transport models moving right around the bay. I mean, to sort of summarize it, when we're doing the that northeastern corner, so we're going from South Melbourne all the way down to Black Rock, that's a generally northerly drift, and that's why we have South Melbourne Beach is quite big. That's the end of that. We move around Frankston, it's probably more on offshore in terms of our sand movement, goes on off. Then we go down to the back of the Mornington Peninsula, over through time, it's coming from the entrance, moving in an easterly direction. But of course, interestingly, when looking at those, as you look through time, it's amazing how many seawalls, because seawalls stop erosion, but in some areas where erosion is your source of sand, then you actually start turning off the sediment supply. Once you're over the western side, it's quite a different sediment system where those muddy ones, it's more linked to the shallow tidal flats going offshore.
Right. Fantastic. Well, unfortunately, that's all the questions we've got time for in the interest of time. So we might see about what we can do about the other. There's some great questions come through that I'm really keen to find out the answers to. So we'll see what we can do about those. But thank you very much, Ben and David, for sharing your knowledge and wisdom with us. And we really hope that these conversations and this knowledge that we've gained can really help us to have a better idea about what has happened in the past and be able to compare that and have conversations around what we're actually seeing right now in real life time, and then to make decisions in the future. So this is what these webinars are all about. And the next one will be on November the 22nd at 6 p.m. and focusing on marine ecosystems and water quality of Port Phillip Bay. But please, everyone from your homes, join us to give a huge round of applause to Ben and David. I know you're all clapping from your living rooms or kitchens, wherever. And on behalf of Paul and myself, thank you again for coming, and we will send out the recording to anyone to watch again. I know I'll be watching a few times, or to those who have the recording. Enjoy and happy watching and learning. Thanks, everyone.